3.6f. So we'd stated that g prime of x is negative 3 over x minus 3 squared. Now notice for all the domain, when we look at this, no matter what we put in x, this is going to equal a negative. And down here, no matter what I put in here, this is going to be a positive, which over is a negative. So if g prime of x is less than 0, then what do we know? We know g is decreasing. So g of x is decreasing on negative infinity to 3 and 3 to infinity. Okay. Now, if it's totally decreasing, we're not going to have an inflection points, right? And the next question is find inflection points. Find inflection points. Well, we know there's not going to be inflection points if we're not going to be concaving down, concaving up. However, we could have concaving down, and then we can have a vertical asymptote, and then concaving up. Who knows, right? So let's test it. Find the inflection points. In order to do that, we'd need to find d g double prime x. To save time, I'm just going to write what that is. That's 6x minus 18 over x minus 3 to the 4th. Okay? Now we set that equal to 0. When we set that equal to 0, we always set the numerator equal to 0, because for this to be 0, the numerator would have to be 0. It doesn't matter what's in the denominator, right? Okay, so setting that equal to 0, we're just going to set the numerator equal to 0. Solving, we bring the 18 on the other side, and x is going to equal 3. Okay, but we have a problem here. X equals 3 is the inflection point, but x cannot equal 3. Can you see that? X cannot equal 3. So we say, therefore, conflict, x cannot equal 3, therefore, no inflection point. Okay, so let's keep going. How about concaving up and concaving down? Okay, so next one, concave. We're looking for concave up or down. Okay, so recall we didn't have any inflection point. What we do know is at 3 we have a vertical asymptote. All right, now what we have to look for is f double prime to see what happens to that. I just took that on the other side, so let's go back to f double prime. G double prime, that's what we were working with. Okay, we stated that G double prime was 6x minus 18 all over x minus 3 to the 4th. X minus 3 to the 4th. Okay, now for all x, no matter what we put in here, right, we're going to get a positive. Now here, we could get a positive or a negative depending what we put in. If we put in a number less than 2, okay, so we're going to look right here at g double prime 2, because 2 is less than 3, right? If I put a 2 in there, we get 12 minus 18, which is going to be negative. So this is going to be negative. Negative means what? Concave down, right? Okay, next one. Bigger than 3, we're going to try g double prime 4. If we put a 4 in there, we're going to get a positive. So we're going to have concave up. So what's happening is basically what we talked about before. Even though we don't have an inflection point, we're concaving down and concaving up. The reason we don't is because we've got this vertical asymptote. Okay. So if we were to roughly draw this graph, I'm just going to do a rough sketch so you can see what's going on. This is at 3. Here's our vertical asymptote. And this is what's going on. This concaves up, and this concaves down. we did have an intercept right there at -1.